Hi guys, so welcome to the second session for strength of materials. So today we'll be learning about strains and how they spread. So writing with the first topic for today's session, we have Poisson's ratio. So what is Poisson's ratio? Suppose a body is there. We provide some force. Now, if we take this direction as x, the other direction as y, and the other direction as z, due to this force applied in x, there will be some change in dimension in z as well as y. Agree? That change in direction can be measured with the help of Poisson's ratio mu. Okay, mu or m. It is in some books they call it m also. Now mu and m, these are all the same thing. I will be taking mu in my examples. Can be given by ratio of lateral strain by linear strain. Yeah, this is the thing. This is absolute, that means we are taking the positive value, but strictly speaking it will be minus of lateral strain by linear strain. Why minus? Let me tell you guys. Linear strain is nothing but the strain in which direction the force is applied. In this example, x is the direction where the force is applied, so strain in x direction, epsilon x, is the linear strain. Now if you see, force is applied in x direction, so there will be elongation in x direction, right? Once there is elongation in x direction, epsilon x becomes positive. Okay, so there will be decompression in y as well as z direction. There will be decrease in length, so epsilon y and epsilon z will be negative in nature. They will decrease, so lateral strain will decrease, so there is a minus sign. Y or z, both are lateral only. Linear strain in the direction where the force is applied is increasing, so there is a plus sign. Got it? So this has been asked already in the GATE paper, and the value of mu will be 1 by 3 or 0.33 for most of the engineering materials. You have to remember this, engineering materials. Okay, now I'm going to write something called generalized Hooke's law. Okay, we have epsilon x, y and z. This can be written as sigma by E. You know, stress by strain is equals to Young's modulus or modulus of elasticity, but just by interchanging both. Now if we talk about 3D, Poisson's ratio will come into picture. If strain in x direction we have to find, then sigma x by E will be the linear and the lateral will be multiplied by the Poisson's ratio, that is y and z. Similarly, in y direction we are finding x, z. Similarly, you can write for z also. Okay, now I have already discussed one relation, tau is equals to g gamma. Here g is modulus of rigidity or rigidity modulus. Angular strain is gamma. It is the change in the angle by the original angle. Tau is shear stress. Yeah. Now coming to K. K is called as bulk modulus. Yeah. So bulk modulus K is given by spherical stress. You have to remember this, guys. These will be used in the problems. By volumetric strain. Yes. Similarly, these two, there will be one more. This was already discussed in the chapter 1. This and this. So this is bulk modulus, and to write it, spherical stress will be given by delta P and volumetric strain will be given by delta V by V. Change in volume by original volume is called volumetric strain. It will be followed by a minus sign. Why? We will come to know in the further chapters. So this is the thing. Okay. Also, this delta P is also called as hydrostatic pressure. When we do fluid mechanics, we'll come across this term. Okay. Now next is volumetric strain. Volumetric strain. Yeah, volumetric strain is given by epsilon V, which is dV by V. Change in volume by original volume is called volumetric strain. If we take a cuboid of dimensions x, y and z, in that case volume will be equals to x, y, z. Agree? Now if we differentiate it, we know this volume is a function of x, y as well as z. So if we want to differentiate it, we have to go with total derivatives. So dV is dou v by dou x dx plus dou v by dou y dy. Similarly, okay, this we will come across in maths, calculus. So after that, if you want to find dV by V, that is volumetric strain, divide the full thing by V, right, on both the sides, LHS and RHS. Now this will become volumetric strain. What it becomes here, you see, dou V by dou x. If you differentiate this with respect to x, y and z are constant, this is partial derivative, so it will become yz by v into dx. Yz by v into dx. Similarly, we have xz dy by v plus xy dz by v. Now v, as we know, x, y, z is the value of v. So substituting it here, we get yz cancels. It becomes dx by x. Similarly here also dy by y and dz by z it will become. So that is nothing but dx by x, change in x direction by the original length, change in length by original length. What is this? This is epsilon x, y and z. Got it? So volumetric strain can also be written as the sum of the individual strains in all the three directions. Got it? Now one more way we can write using Hooke's law also. Epsilon V is nothing but, these are important formulas, please remember them. Using generalized Hooke law, you can derive this equation. Derivation is not there, forget. epsilon v is nothing but sigma x plus y plus z into 1 minus 2 mu by E. Okay, you can have a MCQ question based on this. It has been asked a lot of times. Okay, also I will give you some points now. Mu is equals to 0.5 if the Poisson's ratio becomes 0.5, then what happens to volumetric strain? See here, if this becomes 0.5, 2 into 0.5 is 1, 1 minus 1 becomes 0, this term becomes 0, this full thing becomes 0, then volumetric strain is 0. Correct? Now secondly, if sum of the mutually perpendicular stresses is 0, that is sigma x plus y plus z is 0, then volumetric strain becomes 0, right? See, if this term becomes 0, then the volumetric strain becomes 0. Correct? Now we will come to volumetric strain for a cylinder. See, the cylinder will look something like this, right? So taking this as x and this as y and the height as z, x and y as the diameters and both the x and y directions are same, strain in x and y will be same in magnitude, so it will become, so this is in x direction, this is in y direction, and in z direction we have epsilon L across its length L, we have this. So ultimately volumetric strain for the cylinder will become 2 times epsilon D plus epsilon L. Got it? Similarly, if we see for a sphere, what will it become? It will become volumetric strain is 3 times epsilon D, because in all the directions it will be in same, as the diameters are same in all the directions, the dimensions. Now very important, it has been asked many times, relationship between E, G, mu and K. First relation, E is 2G 1 plus mu. Second is E is 3K 1 minus 2 mu. You have to remember these two relations, very important. Okay, now few points just to remember. For an isotropic homogeneous material, there are two independent elastic constants. What do you mean by independent elastic constant? Is E, G, these are called as elastic constant. Mu, K, these are called as elastic constant. For an isotropic which has same properties in all the direction, homogeneous material made up of same material throughout the body, there will be at least two independent elastic constant, that is at least. Now wood is anisotropic, it won't have same nature in all the directions. RCC is a composite material which comprises of concrete plus steel. Yeah, for a general material, for a general material, we have 81 independent elastic constants. Remember this number. Okay, so these are the things. Thank you guys. This is the end of the theory sessions. From next video onwards, we'll be solving problems based on these topics. So please go through them, revise them, and when you are confident, go to the problem section. Thank you guys. Please do subscribe to my channel for further information and videos.